All right, so we've had a lot of questions recently about the Milky Way.
Our galactic home.
Yeah, and frankly, I feel like it's time for a really good deep dive into this.
Definitely. There's a lot to unpack,
Oh yeah, so much that it's almost daunting, but
but exciting too.
oh no, right? It's our cosmic address.
Exactly.
And we've been gathering a bunch of research and we're going to try to put it all together in a way that makes sense. Like what is the Milky Way really like? What's in it? Where are we in it? And what's going to happen to it? And hopefully some really cool stuff that people haven't heard before.
Yeah, I think we can definitely deliver on that. We'll be looking at everything from the name itself to the mind-blowing scale of it all and the mystery of dark matter.
Okay, so first off, the name Milky Way. It's such a cool name. Like, where did that even come from?
Well, if you've ever been somewhere really dark, away from city lights, you might have seen it. It's this faint band of light stretching across the sky.
Oh, yeah. I have some pictures.
Right. Well, ancient cultures, they looked up and saw this band and, well, they didn't know what it was, so they imagined it as a river of milk or a road made of milk, which, kind of makes sense when you see it.
It does, actually. I can see that. So, but what is it, like, scientifically speaking?
Okay, scientifically, it's a barred spiral galaxy, which means it's this, well, huge collection of stars, planets, gas, dust, all held together by gravity. And that barred part that refers to a central bar-shaped structure made of stars.
Okay, so, like, how many stars are we talking about here?
Well, that's where things get really interesting.
I bet. It's got to be a lot.
Oh, it is. Early estimates, they said around 100 billion stars.
Mm-hmm.
But, with newer telescopes, infrared ones that can see through dust and all that,
Mm-hmm.
now we think it's more like, well, anywhere between 100 and 400 billion.
Whoa, that's a huge jump.
It is. Shows just how much we're still learning, even about our own galaxy. And it's all held within this structure, right?
Yeah, so tell me about the structure. What does it look like?
Well, think of it kind of like this. There's a central bulge, right? And around that is a flattened disk. And in that disk are the spiral arms. And surrounding all of this is a much larger but less dense halo.
And this whole disk is massive.
Oh, yeah. It stretches over 100,000 light years.
That's mind-bogglingly huge.
It is. And all this started forming about 14 billion years ago. So it's pretty old, too.
So that flattened disk, that's where most of the stars are, right? And those spiral arms, they're where new stars are born.
Exactly. That disk is only about 1,000 light years thick, but it stretches out 50,000 light years from the center. So it's like, a cosmic pizza dough, kind of.
I like that analogy.
And those spiral arms, they're not like fixed structures. They're areas where stars are forming. They're dynamic.
Okay, so about those arms, I've heard different numbers, like 4 arms, 2 arms. What's the deal with that?
Yeah, so originally astronomers thought there were 4 main arms. But as we get better data, it seems there are 2 major arms, the Scutum Centaurus arm and the Perseus arm. And the other 2, well, they're more like minor branches or spurs.
Okay. And where are we in all of this?
We're in one of those minor arms, the Orion arm. Sometimes it's called the Orion spur or the local arm. We're nestled between the Sagittarius and Perseus arms, kind of towards the inner edge.
Okay. So we're not even in one of the main arms.
Nope. And there's this other arm, too, the far 3 kiloparsec arm. It's closer to the galactic center. And a kiloparsec, that's like 3,260 light years.
So yeah, we're pretty far out. Okay, so you mentioned the central bulge. What's going on there?
The central bulge is like a densely packed region. It's kind of peanut-shaped, actually. It's got about 10 billion stars, mostly older ones, so they look kind of reddish. And this bulge, it's what makes the Milky Way a barred spiral. And what's cool is it's got a mix of really old metal-poor stars and some younger metal-rich ones, and their orbits are kind of all over the place. The bar itself is about 10,000 light years long.
Whoa. Okay, and what about that halo you mentioned? What's out there?
The halo is this huge spherical region surrounding the disk and the bulge. It's much more spread out, not as dense. It's got these things called globular clusters, which are these ancient groups of stars, like some of the oldest stars in the Milky Way, and also individual stars, mostly old metal-poor ones. The halo itself extends about 100,000 light years.
So old stars and globular clusters. And you mentioned metal-poor stars earlier. What does that even mean?
Yeah, so in astronomy, when we say metals, we're talking about any element heavier than hydrogen and helium.
Mm-hmm.
It's a little weird, but that's just how it is. So we have population I stars, like our sun. They're younger and metal-rich, mostly found in the disk. Population II stars are older, metal-poor, found in the halo and the bulge. And there's even this theoretical population 3, the very first stars, almost entirely hydrogen and helium, but we haven't found any of those yet.
Okay, that makes sense. And And what about the space between the stars? Is it truly empty?
No, not at all. It's called the interstellar medium. It's mostly gas, hydrogen, and helium, the raw material for new stars. It's where stars are born, basically.
And what about dust?
Dust, too. It's a small percentage of the interstellar medium, but it's important. It blocks visible light, which makes it harder for us to see things in the Milky Way.
Ah, so that's why we need infrared and radio telescopes to really see what's going on.
Exactly. And this dust, it's what makes it difficult to pinpoint exactly where we are in the galaxy.
So where are we exactly?
We're in that Orion arm, remember, nestled between the Sagittarius and Perseus arms toward the inner edge of the arm, which is about 3,500 light years wide.
Right, right. And how far are we from the galactic center?
So early estimates put us about 24,000 light years away, but now we think it's closer to 26,000, maybe even a bit more. We're about halfway to the visible edge of the disk, or roughly a third of the way out from the bulge.
Okay. And are we just like sitting here?
Oh, no, no, no. We're moving.
Observing.
We're orbiting the galactic center at a speed of about 515,000 miles per hour.
Seriously. That's crazy fast.
It is. And one full orbit that takes about 230 to 250 million years, we call that a galactic year.
So our planet has only been around for a fraction of a galactic year.
Exactly. We're zipping around at about 220 kilometers per second, which, it sounds like a lot, but it's actually a tiny fraction of the speed of light.
So just to recap, the Milky Way's disk is about 100,000 light years across, right?
Yes, give or take.
And it's pretty thin, only 1,000 light years or so, at least the main part.
Yeah, there's a thicker component too, a few thousand light years thick.
And the stellar halo stretches out even further to 100,000 light years. But the dark matter halo, that's way bigger, right?
Oh yeah, potentially 20 times larger.
Crazy.
It is. And the total mass of the Milky Way, well, that's somewhere between 890 billion and 1.54 trillion times the mass of the sun.
So much mass.
And about 90% of that is dark matter.
So we can't even see most of what's holding our galaxy together.
Pretty wild, huh? But, at the heart of all this is something even more mind-blowing.
Oh, you mean Sagittarius A?
That's the one. That supermassive black hole sitting right at the center of the Milky Way.
I've heard of it, yeah.
It's a bright radio source, about 4 million times the mass of the sun. But here's the thing. Its diameter is smaller than the orbit of Mercury.
What? How is that even possible?
That's black holes for you. It emits radiation across the spectrum. But for the most part, it's dormant. We even have a picture of it now.
That's pretty cool. And how far away is it?
About 26,000 light years, which is pretty close, all things considered. And, it's not just sitting there, it's influencing the whole galaxy.
How so?
Well, its gravity is so strong that it dominates the dynamics of the galactic center. It governs the orbits of stars nearby, and it grows as matter falls into it. And it's probably influencing the evolution of the entire galaxy through energy feedback. Although it's mostly quiet now, it does flare up occasionally, sending out bursts of radiation.
So how did this whole amazing structure with its black hole and billions of stars come to be?
Well, it started about 14 billion years ago, probably from the collapse of giant gas clouds. But it wasn't just one big collapse. It was likely the merging of smaller galaxies.
Like a bunch of smaller galaxies coming together?
Exactly. And we know there have been some pretty big mergers in the Milky Way's past. One of the biggest was the Gaia-Enceladus event, about 10 to 11 billion years ago. That one really shook things up and probably helped shape the thick disk we see today. And, a good chunk of the halo stars, they might be from other galaxies that were absorbed by the Milky Way.
Wow, so the Milky Way has been cannibalizing other galaxies.
In a way, yeah. It's all part of how galaxies evolve.
So we had the initial disk formation around 13 billion years ago, then a period of mergers, and then the thinner disk formed, where our sun was born about 4.5 billion years ago.
That's about right, yeah.
And the last 8 billion years have been pretty quiet, relatively speaking.
Yeah, no major mergers. But that's about to change.
Oh, right. The Andromeda galaxy. It's coming right for us, isn't it?
Yep. It's hurtling towards us at about 110 kilometers per second.
When is this going to happen?
Current estimates say the collision will start in about 4.5 billion years.
So what's going to happen? Will the Milky Way survive?
Well, it won't be the Milky Way anymore. The two galaxies will merge. It'll be a long process, millions of years, but the end result will likely be a giant elliptical galaxy.
Wow, a whole new galaxy.
Yeah, it's pretty mind-blowing to think about. And our solar system, well, it's unlikely that we'll directly collide with another star, but there's a good chance we'll be pushed further out from the galactic center. And there's even a small chance we could be ejected from the merged galaxy altogether.
So our whole cosmic neighborhood is going to change.
Definitely. But, long before then, the sun will have expanded and made Earth uninhabitable.
Right, so it's not like we'll be around to see it anyway. But still, it's pretty amazing to think about. This galaxy we live in, it's constantly changing, evolving, and it has this incredible future ahead of it.
And that's just one galaxy among billions.
So even though we're just a tiny speck in this vast universe, we're part of something truly awe-inspiring, something that makes you think about our place in the cosmos and the grand scheme of things.
It's a humbling thought and one worth pondering. Thanks for listening.
And keep those questions coming.
Yeah, we love exploring the universe with you.
We'll see you next time.
Bye.